So if you use a lot of Milwaukee M12 batteries and tools, you'll find that some other tools have problems where they shut down like this. Well, is it the battery or is it the tool causing the problem? Well, come with me because Milwaukee has made an announcement on this very subject. So Milwaukee recently flew me out to Milwaukee to see their new tools at their pipeline event, which is an event designed to basically showcase all the brand new stuff coming out for the up and coming year. Milwaukee Tools has redesigned the M12 batteries. So they claim that they produce more power and torque on the tools, and they're specifically designed for mechanics and automotive repair. They are made out of a completely different material, and they're producing up to 25% more power out of the battery. So they have a 5.0 XC battery and a 2.50 XC battery. So now the batteries are made out of a chemical resistance plastic, and also that's a much softer material, so it's less brittle, so it'll take falls and shock better. All the latches and catches are exactly the same, just made out of a different material, so they stay on the tool better and they don't break when you drop them, is what they're claiming now. So when you're using high demand tools such as the die grinder here, the batteries get really hot, and they're saying that that is the cause for the shutdowns. Is as you're using them, the battery generates a ton of heat, and then it has circuitry inside of it to shut it down to prevent it from overheating. So that's what's going on. So I'll let you listen to the product managers and engineers at Milwaukee and let them explain exactly what the new batteries are like and how they're fixing this problem. So right here they have two drills set up on a dyno, each one set at the exact same specs, and they're running, and what they're doing is they're counting the amount of revolutions it does, and they're measuring the temperature of the battery, and they're doing this with a 4.0 battery and their new high output 5.0 battery, or the XC battery. So the XC is on the right, the 4.0 is on the left.
Minutes on end. That pack's going to get hot. Eventually that pack's going to shut down. And in these kinds of situations, that's when you're going to want to use M12 Batteries high output batteries. These run 25% cooler. So we're going to let this run for several minutes. And we're going to see how much work the XC40 does and compare that to the high output XC50 and see which battery gets more work done. Before we do that, I want to explain what we're seeing on the graph. So on the left, we're seeing how much work the XC40 is doing. And on the right, we're seeing how much work the high output 50 is doing. The colors are actually indicating how cool or how hot they are. They're starting off as blue, but they're eventually going to get warmer and turn red and eventually shut down. In the center, we're showing how much more work one battery is getting done versus the other. You can already see the M12 high output 50 is delivering 15% more work. And we haven't even shut down yet. We're going to keep going. So I'm going to let this keep running, and I'm going to pass it over to Tim Yu to talk to you guys a little bit about runtime and other advantages of high output.
M12 high output batteries can achieve more than 25% in certain high demanding tools and applications through the increased power that's sustained throughout the full discharge. So as the #1 self-compact system in the industry, we're elevating the M12 platform even further, as M12 high output batteries are able to push the capabilities of existing and future tools, just like this Gen 3 impact driver here. So we took a leading subcompact 20-volt competitor, took their impact driver and ran the same application over the full discharge. That completed 64 drills. Compare that to our high output XC50, we deliver over 56% more work, outperforming a 20-volt solution with a smaller form factor and within a 12-volt mark. I'm going to redirect everyone back to the dyno testing. On the left, as you can see, the bar graph displaying red indicates that the XC40 has hit its thermal limit. On the right side, the high output XC50 continues to run. We will let it run its course, and we'll come back to visit this one final time to see how much work the XC50 completes over the XC40. Until then, we'll turn back around and focus on the runtime displays here. Another great example of a long duration application is cutting 2x4 SPFs on our M12 fuel circular saws. Again, running continuously through the full discharge of the battery, our high output XC50 delivered 234 cuts. Same tool, same material, same application, our XC40 battery delivered 186. Again, showcasing that when you step up to M12 high output, you're increasing your productivity, getting more work done per charge. Additionally, high output batteries reduce downtime, reduce the time you spend charging your batteries, allowing you to focus more time on the job and get it done quicker. Now when we talk about M12, it's hard to not mention our best line within transportation maintenance dedicated solutions. We have tools like the tire buffer, the ratchets, the stubby impact. These tools are being used now beyond trades within transportation maintenance, often finding themselves in environments that are prone to potentially corrosive chemicals, greases, solvents that are required to get the job done. Similar to the M18 XC50 resistant battery that launched earlier this month, M12 high output batteries feature a resistant housing that provides increased protection to those oils, greases, and solvents commonly found within transportation maintenance and manufacturing environments. This shows Milwaukee's commitment to deliver trade-focused solutions, whether it's M18 or M12, within transportation maintenance to enhance the overall experience of our M12 platform. And now I can hear it's already gotten a little bit quiet, so why don't we go swing our way over and check what happened with our dyno. Wow. Okay, so let's go back and explain a little bit about what we're seeing. So like I said, XC4 shut off minutes ago, and it delivered about 4,000 revolutions here. And over here, we've got the 5.0 just shutting down. It's hit its overtemp. And because M12 output is able to run 25% cooler, on these high load applications, the benefit you get in the amount of work done only gets higher and higher the more demanding the job is. So in situations like this, the high output 5.0 is delivering as high as 85% more work than the XC40 on this time. So again, taking it back to that example, working on a die grinder, working on a bandsaw, working on a really heavy application, and you're running that for minutes on end, that's where you're truly going to see this advantage. The harder you work that battery, the more the advantage you're going to get with high output. All right, well, thank you everyone. Hopefully you all have
same performance as the 5.0. It's hard to distinguish. You can see it's sort of got a matte finish if you were to take that the standard 5.0. But with the M12 high output packs, you can see compared to our existing red lithium batteries, again, more of a matte finish that indicates it has that resistant housing there.
So they're made out of a different plastic, the housing.
Correct.
So is it more durable than the older one, or
yeah? So
as far as breaking?
It's a great question. So we further enhanced the durability within across our M12 high output batteries. So the latches, for example, is something that we made sure to address, enhancing and further increasing the durability within our latches here.
So the batteries themselves are pretty much exactly the same size as the previous models. The cells inside are different though. They run cooler and they produce 25% more power is what they're claiming. So these batteries produce 25% more power and they run cooler, preventing the shutdown of the tools is what they're claiming now. So I will be doing my own tests. Once they send these batteries out to me, I'll be verifying it, doing this exact same test side by side, seeing how they shut down and seeing how much more work you can get out of the tool. So make sure you're subscribed to the channel. I'm Brian Eslick from How To Automotive. I'd like to thank you guys for watching.